I want to test your streaming real quick. Make sure.
Okay.
We don't have to do it.
iPad connected.
Stick it up a little bit. Prepping.
There's so many wires back here that it's just like a.
Yeah, what we're gonna
Death
do
trap.
is, let's say maybe Friday, we'll try to make it, and if you're ever stuck here and you can't go get something, like I'll usually have one or two drinks that are like there.
Grass. Yeah, well, I love cilantro. Okay.
All right, let's pull up on here and make sure.
Jesus, I feel like I'm in the Antarctic.
You can turn it off while I'm not in here. But who put it on 72?
Not me. I swear it wasn't me.
I'm okay with you changing it as long as you change it back.
I got you. How are y'all feeling today? Great. Wonderful.
Caught a bunch of fish, so.
Hmm?
Caught a bunch of fish, so I'm feeling pretty good.
Oh, so you've been outside today. Okay.
I want to get any of y'all on that transmitter too. Like that's one thing that's not really an ELT that pretty good to know. Like since we've got it running, like tomorrow night we're gonna calibrate it with the pumps and piping guys. But if you're interested in that, like it puts out a 4 to 20 milliamp signal, which we converted to 0 to 10 volt signal because the input card can only read voltage. And all we did was put a 500 ohm resistor there, and that 0 to 20 milliamps through that 500 ohms would go from 0 to 100 volts.
The Somerton thing's not popping up on the screen mirror.
Okay, so what you need to do is, all right, so this is the only weird thing. Go to here, and you need to be on Rob SCADA. So
Okay, let me just go to settings.
all right, so I set up that router so that like it would actually talk to this stuff, and it's like we love tacos. No, that's our normal LUB, WLUB, and the A is an @ sign. That's our normal password for it. All right, because they're about to give us a server, right? And all the
God dang it.
things is going to be this. Like, if it's a password that students should know.
Okay. Well,
Okay.
I apparently don't know how to type, so.
Like, I'm feeling better now. Pens are bad. Like, students get that when they know the password. So you're elite hacker taco, right?
Wow.
When somebody wants extra credit, when they learn Ohm's law.
You really give these out? Why didn't you do this with us?
Because I didn't like
That's
it.
where his favorites.
This one was
I
for
think not.
Ashley because I say I love you whole punch.
Oh.
So that one didn't go to Steven. Unless she's real hot.
And we're streaming.
That's fine. When I try to get them to do power as easy as pie.
Huh? Easy as pie.
You know power equals current times voltage.
Yeah.
Yeah, I've got a butt machine back there. We're gonna make automatic but machine out of it. So you just feed it pictures and then.
Pretty legit. Whenever you want to leave, you're good. I mean, I'm good to go. As long I'm set up, I'm streaming, I'm looking at my baby and all my apps. So you're good to go. Alrighty, fellas. Who likes Slim Jims? Does anybody like Slim Jims? Love Slim Jims. I love Slim Jims. Alright.
What are we learning about today?
Motors, my friend. Mm-hmm.
I would have never.
Bye. See you tomorrow, Rob. But seriously, we are learning about motors today. I'm not just being a smart butt. We're not learning about transformers today. We're learning about motors.
Robbie was telling us about transformers.
Oh, yeah? Not probably type of transformer that goes along with his class, I would think. Like how his kid likes transformers? Okay. Oh yeah, I forgot to flip all these around.
Control I.
Motor control 1. But that's just how it's on the book, so I just did it like that. Alright. Hey Sam. Okie dokie. Alright, we're about to get into it. Okay. I gotta flip every single one of these around because I wrote on it the opposite freaking direction. How dumb. Alright. So, what would be your definition of a motor?
Something that runs electrical or
You're on the right path.
lights.
So it converts electrical energy into mechanical energy, right? That's what a motor does.
Oh, an electric.
Yeah, we're talking about motors that we're wiring up,
Yeah,
not like a
Hold
mo.
on now.
Not there's different
That's
types of
not
motors.
That's not changed from electric to. whatever.
Yeah, so like an electrical motor, let's just say that converts electrical energy into mechanical energy. And so, what would be an example of a motor in our home? What would have motors in them?
AC.
Ceiling fans.
Like a
Some
refrigerator.
people don't have air conditioning.
A wash.
Yeah, washing machine. Do you have a washing machine, Dylan?
I take it to my mom's house.
Well, her washing machine has a motor in it.
No, she just hangs it on the.
She hand wash.
Actually, hand washing.
Oh, okay. How do motors relate to transformers?
Motor is it?
Right.
Hey.
Smart, man.
Pay attention.
Yeah.
Even though
Apparently
I
I did.
fell asleep.
What kind of motors do y'all know of? Like, what type of electrical motors do y'all know of? Any electrical motors?
You got 3-phase, single phase.
Mm-hmm. But
You
like,
got 480.
you would be thinking about like there's AC and DC. DC's not as relevant, but we're still going to touch on them just so we can say that we did. Okay. Sorry. Some of these I have to flip literally because I'm crazy. Okay. So it's an extended version of a transformer. They convert electrical energy into mechanical energy.
So does transformers convert electrical energy?
Transformers are doing nothing. They do not destroy or create energy. It is simply to step up or step down voltage. Right? We learned that. A transformer has no moving parts. So a motor has a primary that is stationary, and that's called the stature.
So like, if a transformer doesn't transfer into mechanical energy, why is the motor in a transformer?
A motor is just an extended version of a transformer.
Okay. The
So, like-
mechanical the extended version.
So as like a motor, it has a primary and a stationary. So like a primary and a secondary, like a transformer,
Yeah.
but its secondary is the moving part, and that's called the rotor. So that's why you can say that a motor is a transformer basically, because it is transforming electrical energy into mechanical energy. But whereas a transformer is just transforming either a high voltage to a low voltage or vice versa, right?
So when or like, when people say the start winding and the run winding, how does that play a part?
That would, like, the start winding would be your primary, I'm sure, and then like your run would be the rotor.
Okay.
Is what that would be. So these are just windings, your stator and your rotor. So like your stator stays. Like you know how I think of words to come up. Your rotor runs. Your rotor runs, your stator stays, right? All right. Gotta do a little flipperoo.
You're getting really good at making these.
I've stayed up for hours, guys, trying to study for y'all
I,
and for
I
myself.
like these or it like this better than the one last week.
Yeah, I mean I do too, because when we get into like how we're gonna wire them up, I can actually show you and stuff. So, and when a motor's doing work, its shaft is turning and an EMF is created, and of course EMF stands for
Electromagnetic field.
right,
I read it on.
just like transformers. And this works against the applied voltage and reduces the current flowing through the coils of the motor. So, it reduces current flow. Let's see here. I don't have to
Can't read that.
I don't have to do this every single time. It was just the ones I wrote upside down. So, there are 3 main types of DC motor, and that's going to be, the first one's going to be series. And their field windings are connected in series with the armature. And I'm going to show you how a motor's broke down here in a minute. I got you a really good drawing. It could win like a
Is another
art
type of motor
contest.
a parallel?
No.
Oh,
Just wait, we'll get to that. Anyway. Alright, so they're generally used where high starting torque is needed and speed variations are possible. So some examples you're going to see series DC motors in is cranes, air compressors, vacuums, sewing machines. Yeah, because think about it. Used where high starting torque is needed. Are you going to want to have to crank up your vacuum and like and let it idle for 5 minutes? Or are you going to want to plug it in and vacuum, right?
like
Yeah.
on some machines.
So like torque is like, if you got low starting torque, that means it's going to take a minute for that motor to get up and go, right? If you have high starting torque, that motor's like, all right, I'm ready to go. Boom. Like, I'm up to speed. I'm producing all I can produce in a certain limited amount of time. Okay? Does that make more sense? Also with air compressors, you want them at a high starting torque. That way they can build up to the air pressure you need to, say, air up your lawnmower tire, right? So you don't want to have to wait 30 minutes for it to get to starting torque and then wait on your air pressure to build, right?
Yeah.
Okay. Does that kind of make sense, Dylan?
It makes enough. I'm good.
What are you confused about?
I'm not confused about nothing.
Okay. All right. You got it, Sam?
Yeah.
All right.
Shouldn't
The next one is shunt. And their field windings are connected in parallel with the armature. So they're used whenever a stable speed is needed. So if you know a motor's going to run for 12 hours out of the day, you'd probably use this type in an industrial setting.
It's like a drill press.
Yeah, kind of. I mean, like, you know that motor is going to need to be at a consistent, stable speed for however many hours of the day, right? So, like, blowers and fans, machine tools, drilling machines, etc., like what you just said, and, like, you know, like ID fans or something is what you would see those in. Let me turn this off. All right. Now let's get on to the next one, and that's going to be compound. And they're wound for a shunt field, but with a few turns of series winding on top. So this motor is a combo of the shunt, has a combo of the shunt and series characteristics.
Yeah, I was kind of wondering what the next one would be, since the first one was kind of series and the next one.
Right, so this is just a compound of both of what we just talked about. And their starting torque will be higher than a shunt motor, but less than the series. So like some examples of what they might be used for are conveyor belts, turntables, dynamic braking, reversing, stuff of that nature. Like, you don't have to have it 0 to 100, but you don't have to have, you know, you need a little bit more than 0 to 50 too. So,
Stuff like variable.
Huh?
And so motors have to be like,
yeah, I mean, it's just used where I guess you could wire it up in either like series or shunt or the compound or whatever. Like, and we'll get into that a little bit more when we go to AC. Like, this was just a touch of DC. Like, DC is not as important as AC because all we deal with is AC, right? I mean, unless you're in like you're working on a crane or something, that's gonna have a DC motor in it or something. But like, if you're in the electrical world, 9 times out of 10, it's not gonna be DC. It's gonna be AC. So this is the components of a motor, and look at my beautiful drawing that I drew for you guys. It's beautiful.
that really does kind of look like one of the crane motors.
Well, so the bearing supports the rotating shaft of the rotor. Your rotor is obviously the rotating part, and that's number 2. 3 is your stature. Stature, whatever. I'm probably not stator. I never can pronounce it right. So that's the part generating force used to rotate the rotor. And 4 is the bracket. So bearing supporting the part integral for the stator. So like your bracket is just the housing for your stator.
Stator. Confused me when we opened up in 3 phases. What is between your winding and your rotor that keeps it from grinding itself down and stuff like that?
That would be, are you talking about between a bearing?
So, but I mean, like, there's a level of contact between it.
Are you talking about between your rotor and your stator?
Or that, yeah, that's what I mean.
So like your primary, which is your stator, and your secondary, which is your rotor? Like, what keeps them from like rubbing together is what you're
when you have
asking?
to replace those motors.
Right. So like every motor, like we'll get into this a little bit later too, like has insulation and stuff. So like first of all, your rotor is never supposed to move like any direction besides like rotating. So if it ever was to become loose, it would damage the motor.
Yeah.
So it's set in a certain position. It's not going to touch your stator or whatever, however I'm supposed to say it, unless something's wrong with it. So like,
Those motors got something wrong.
so they're touching.
Yeah, like the rotor's touching around the. That's why it sounds so horrible when you.
Well, yeah, that's not supposed to happen. Like the rotor is supposed to be encased in whatever, so you can have an open case or you can have a closed case motor. And it's supposed to not touch anything because the rotor is supposed to just rotate without touching a single thing. So if it is touching, like if it's touching the casing or, I mean, it can be.
When you pull that drill, like when you on that.
You can hear it hitting something.
Yeah, you can hear it grinding.
That's definitely not right. Like you should hear the motor run, but it shouldn't be like
It sounds like
something's happening in it. Yeah, okay. Well, we may need to look
I'll
at that.
into it.
All right, and then I added y'all a little fun fact. Take it as you will. In Chinese, the words stator and rotor are pronounced as, how do you think those are pronounced? I say dingsy and zwanzi, but I know it's like dingzai. Yeah. But that's just another cool way to remember, like your stator is your dingsy and your rotor is your zwanzi. I just thought that was cool.
Y'all, drop that dingsy.
Drop that dingsy now. All right. So now we're getting into AC motors, and that's what we're here for, right?
Oh, you didn't have to flip this.
No, because I actually wrote these right. So, okay, so an AC motor, it uses alternating current, obviously, by the name, right? To produce rotation. And it also has a stator and a rotor. And AC motors have several advantages over DC motors because they only have 2 bearings that can wear out. And there are no brushes to wear because AC motors do not have a commutator. So whenever these was invented, they're less maintenance, less wear and tear. Like, they're relatively better than DC motors. Okay. So, single phase AC motors. And they're used in appliances like air conditioners, washing machines, refrigerators, like what we was talking about earlier. That's what you would find in your home appliances, right? So the first type is shaded pole motors, and they use a shaded stator pole for starting. And they can be used in exhaust fans, hair dryers, table fans, Then you have split phase, and that includes a running winding, which is your main winding, and a starting winding, which is your auxiliary. So what we was just saying was your running winding or your main winding would have been your start winding, right? And then what'd you say the other one they called it?
Run winding.
Okay, so wait, no, backwards. I said it
Run
backwards.
winding will be the main and start winding will be.
Right, so it'd be auxiliary. Yeah.
The way I was explained whenever I was starting to do air conditioning, the reason they have a capacitor is to get just enough voltage to get the start winding,
Right. So get it rotating, build the electromagnetic field or whatever.
which those capacitors that they use on air conditioners, it stores up energy up to about 400 and some volts,
Mm-hmm.
and that's what kicks it off.
I got you. So they can be used in washing machines, oil burners, small pumps and blowers, etc. And a capacitor motor, what you're talking about, would be in an AC unit. Includes a capacitor in addition to the running and starting windings. All right, and here we go. Reactance is the opposition to the flow of alternating current in a circuit due to inductance. So you're always going to have some type of resistance because this is not a perfect world. So any and everything like is going to have resistance, right? Right, Sam? Okay. So move on to three-phase motors. They're mostly used in applications ranging from fractional horsepower to over 500 HP. So these are going to be your big boys, what you're going to see in plants and, you know, wherever you need a lot of energy produced, right? So an induction motor has no physical electrical connection to the rotor. These motors have no brushes that wear or require maintenance. I know my writing's awful. And then single voltage, they operate at only one voltage level. And all three-phase motors are either Y or delta. So that's something to remember. Like, if you're working with a three-phase motor, it's either going to be in Y or delta, period.
So those don't switch. Like you
Now-
buy the motor as
Right, now we're about to get to it because there's a dual voltage. So single voltage don't switch. So if you got a single voltage, that means you're either going to have a Y or a delta, right?
yeah.
So the smart thing to do is buy you a dual voltage motor. So just like in transformers, depending on voltage is how a motor is wired up. So if it's low voltage, what do you need? Parallel. If it's high voltage, what do you need? Series, right? So like just like the transformers, remember how if we wanted it to step down from 480 to 120, what do we wire it up in? High voltage, remember? So 480 is your high. So if we wanted to step down that transformer from 480 to 120, we wired it up in series. But if we wanted to step it down from 240 to 120, what did we wire it up in? So always remember, low voltage equals parallel, high voltage equals series. Right? Okay. And then most three-phase motors are dual voltage. And they can be used with a lower high voltage. And that type of motor is ideal because it can use two different line voltages. So if you've got a 240 or 480 or whatever. And the example in the book was 230 to 460. But I think it's just easier just to say, 240 to 480 because that's what we're used to dealing with, right?
Yeah.
And so on a dual voltage motor, you always want to choose that higher voltage when it's an option. Because more voltage equals less of what? If your volts go up, what must come down? Yep, your current. And current is what puts wear and tear on your equipment, right? So, if voltage goes up, current must go down, right? And that's just basic Ohm's law.
So that's kind of the reason that three phases are usually more efficient.
All right, now we're getting into... All right, first of all, let's go ahead and throw that out there that you always... that's very important. Any information you need to know about a motor, it should be on the nameplate. So if you need to know, what temp can this motor resist, or like up to what temperature, right? Or, what is the rate speed of this? So in this limited amount of time, what should this motor be producing? And if it's not, there's a problem with your motor. So that's how you troubleshoot. Like, the first thing I would do is look at my nameplate if I'm troubleshooting something. Like, what could have happened, and was it operating within its capacity to operate? You get what I'm saying? So, I just threw that out there. Nameplates are very important. Okay, so this is a single voltage Y 3-phase motor. So each end of the 3 phases are internally connected, and they're brought out externally. So that would mean, let me choose a different color here. We're going to do purple. Okay, so that would mean your T1 would go to L1. Your T2 would come out here and would go to L2. Your T3 would come out here and it'd go to L3. And that's why it's a single voltage Y 3-phase. So and this is a Y, so if you wanted it to go to, I don't know, like 480, that's what you would have. So then over here, they're wired end to end to form a completely closed loop circuit. So let me go to that page I was talking about. I'm supposed to be following along with myself here, but I'm not. Where am I here? Oh, okay. Alright, here I am. Oh, by the way, I didn't go over. Yeah, I did.
Aren't those quizzes still not?
Okay.
No, I don't.
Alright.
Make sure I absorb all information I need to. Or I can just Google it on my phone. Never mind. It's using your resources, man.
Whenever I took my quiz, I did them all, then I had to go back and erase every single answer I made, and just copy it.
Okay, so talking about single voltage 3-phase motors. So I'm just gonna read you the definition out of the book. And it's a motor that operates at only one voltage level. Cool, we understand that, single voltage, right? And they're less expensive to manufacture than dual voltage motors, but then again, they're limited to locations having the same voltage as the motor. So if your motor's only rated to be able to withstand 240 volts, that's the only application you can use it in. So if your environment requires higher voltage, you got to buy another motor.
So it's an investment.
Right. So, I mean, I really don't get the use for single voltage motors, but I don't know. I mean, if you knew that forever and ever you're only going to require this amount of voltage, I guess they're cheaper, and I guess they would be a better investment for that scenario.
A lot of motors, it's really just a scenario-based thing anyway.
I mean, like, say a motor run into a pump in a plant. That motor is never going to do nothing else in its whole entire life but run that pump in a plant. So you're always going to know consistently what voltage it's going to require, et cetera, et cetera. So, and all 3-phase motors are wired so that the phases are connected together in either a Y or delta configuration. We've already talked about that. So, in a single voltage Y 3-phase, one end of each of the 3 phases, we've already talked about that, is connected to the other phases, and the remaining end of each phase is brought out externally and connected to a power line. So literally, this is just going to your A, B, and C phase directly from your motor. That's what it does. And so, in the delta over here, we have each winding is wired end to end to form a completely closed loop circuit. And at each point where the phases are connected, leads are brought out externally and labeled, blah, blah, blah. We're not going to go over that. 3-phase line supplying power to the delta motor must have the same voltage and frequency rating as the motor. So, once again, single single voltage motors. I just don't really care for them, but it's all about the application you use them in, I guess. All right. Let's see. Here we go. Here's your dual voltage Y. Yeah. Did I go over this one? Yeah, we did. Okay, making sure. All right. So your dual voltage Y. And most three-phase motors are made so they can be connected for either of two voltages. So, the higher voltage is preferred when choice between voltages is available. But see, like, that's why you want to choose the higher voltage, because here in the book it literally tells you the motor uses the same amount of power and gives the same horsepower output for either high or low voltage. But as the voltage is doubled, so if it jumps from 240 to 480, or in the book's case 230 to 460, the current is cut in half. So using a reduced current enables the use of a smaller wire size, which reduces the costs of installation. So you can kind of click in your head why you would want to reduce the current now, because you could use smaller wire. It's cheaper all around. So it's just better if you use the higher voltage. And so back to wiring diagrams. A wiring diagram is used to show the terminal numbering system for a dual voltage Y-connected three-phase motor. 9 leads are brought out. So let's look at this. So if you wanted it in high voltage, what does it need to be wired in, guys? High. If you want high voltage and low voltage, what have we talked about so many times? If we wanted it high voltage, Sam, I know you know this.
This, if you want it high voltage, you want parallel. Oh,
You always gonna mix up. Series.
series.
You high equals series. I'm giving y'all a quiz on this. I'm sorry. High equals series. Low equals parallel. Right?
I know
So-
guys don't know about series.
And it
Well-
will never be different. Okay, you gotta remember this.
You understand?
Yeah, low parallel, high series.
Low parallel, high series.
High series, low parallel.
Yep. Okay. So look at this. So if you want it in high voltage, can you read this diagram and understand what's going on with high voltage? What's happening?
Well, you put the
What does the L stand for? Line, right?
line.
And these are just your contacts for your motor. Like I call them contacts, but they're just leads for your motor.
Yeah, they're close.
So you're going to take your line 1 and connect it to T1. And then you're going to take your line 2 and connect it to T2, line 3 and connect it to T3. So since we want it high voltage, it's pretty simple and very self-explanatory what we're about to do here, right? So where are we going to connect T5? To T8, right? Where are we going to connect T9? To T6. Where are we going to connect T7 to T4? Literally, that diagram tells you that. T7 to T4, T7 to T4, T8 to T5, T8 to T5, T9 to T6, T9 to T6. And that's how you would wire up a high voltage Y three-phase or dual voltage Y three-phase motor for high voltage. You need it in series, so literally all of this is connected, right? Now, if we wanted it in low voltage, if we wanted it in low voltage, what would we do? Parallel, right? Yep, you said it. So, if we want it in parallel, we're going to do T4 to T5 to T6, right? So you're going to go T4, T5, T6. All that's interconnected. So that's one parallel circuit. You get what's happening here? Okay? Now, we would take T2 to T8. From T8, then we would go from T3 to T9. And then we would go from T1, wherever that might be. Where's T1 at? T1 down here.
Right.
I've already done that. What did I do?
You wrote T2 twice. T1's at the top, ain't it? No, wait. T1 would be at the bottom and T2 would be at the top.
That's T1. This is T1. It just looks like a 2.
Oh.
No, I shouldn't have took T1 goes to 7. I'm sorry. Damn. T1 goes to 7. So, boom. And then T3 goes to 9. Boom. And then T2 goes to 8. Boom. And then all of those were connected. Why am I doing that? Don't do that. Don't do that. You jinxed me saying I was good at this. Don't do that. Don't do that. So your T4, T5, and T6 are all connected. And that's how you would do it in parallel. Because see how you still, see how, this, let me do a different color. This is what clicked in my brain earlier. So you see how this area right here looks like how the transformer did on the back of that transformer? And remember how if we wanted to wire that transformer up in series, we would connect those two? But since we want them in parallel, we leave that open, right? So that circuit's not touching each other. So you have consistent parallel circuits all throughout. Are you confused now? You are?
No,
I think Caden's confused. So what are you confused about, Caden?
I'm not confused.
It's just a lot to take in.
I'm really observing.
Okay. So,
I feel like I could do a quiz on this.
but there's always, like, if you're going to wire up a motor, guys, you're going to have a wiring diagram, or you're
Yeah,
not.
they're always going back.
Right, you're not going to know what they're going to want if they don't give you a diagram. So literally, if they give you like a diagram like this over here, that's just basically telling you where your lines are going to go and what your leads are going to be connected to. So you can literally just follow this whole little diagram, right? You can understand that T1 goes to T7.
Yeah.
And you can understand that T4, T5, and T6 are all connected, right? Okay. And you can read the high voltage one. And you can understand how that puts it in series.
Yeah.
In parallel. Okay. And if I start confusing you, just slow me down and tell me, like, hey, I'm kind of confused. Because, I mean, I know y'all get it, but sometimes it's just a lot to take in. Okay. So, we're on to the dual voltage delta, right? So, looking at this high voltage diagram, line 1, line 2, and line 3 all go to their counterparts of T1, T2, and T3. Where does T7 go?
T6.
That's a 4, sorry.
Oh, that's a 4.
So literally, so if we want high voltage, what's it wired in?
Series.
Y'all should not have to think about this.
I'm sorry.
The information was only a few seconds ago.
I still have
Series.
To look, I still have to look down at my hand to make sure it's to the left.
Okay, series, right? Series equals high. Okay. So all you're literally going to do is connect all these. You don't even really have to look at the wiring diagram. You
A
know
couple guys that are always in series.
you know that these are going to be connected just literally right across. It's going to be just a series circuit, right?
Yeah.
Okay. We understand that. If we wanted high voltage, it's in
It's
series.
like series for serious.
Okay, Dylan. Low voltage. So, now this one looks kind of tricky, but it's really not at all. So, once again, your counterpart, your L1, L2, and L3 are going to go to their counterparts. So, that's going to be L3. That's going to be L2. And that's going to be L1. Right?
Yeah.
Okay. So now, where is T1's going to go to T7. And then it's going to go to T6. So, let me make sure I'm not telling you. Yep, okay. So they're all connected. So this is going to bounce around to T7. And then it's going to go to T6. And then we're going to have T2, wherever it might be.
Over there on the right side.
I see. It's going to bounce over to T8, which is in turn going to bounce over to T4. And I know this looks really confusing, like super confusing. And then T3 is going to bounce over to T5. Dang it.
I was going T9.
T3 to T9 and then.
You're right, sorry. You're right. T3. Bounce over to T9, and that bounces down to T5. And this just looks like a whole lot of craziness because I'm not like as good at the book as drawing it. But that is how you'd wire up a delta in parallel. But once again, you know that it's going to be calling for low voltage because you're going to have a line diagram,
Yeah.
and it's going to tell you how to wire it up in parallel. The main thing to remember is that you just know that low voltage is going to equal parallel and high voltage is going to equal series. Right? Okay. Let me remove all that nastiness off there. And like, it gives better examples in the book, but I'm just not a very good artist, so I'd like to see you try. Okay. Once again, that's very, very, very important nameplate information, right? Okay. So AC motor maintenance, just basically they shouldn't be operated in any damp conditions. And when oiling a motor, only oil the bearings. So like, why would you think that would be?
Because it's electrical. I mean, not everything will work.
Right.
Yeah, and some oil is conductive.
Well,
I
yeah.
thought they make some oil that's not.
Well, yeah, of course you would use like non-conductive,
And
but
it will
like,
bring down your.
so just think
How
about it.
fast you
Yeah,
spin,
and
they will
if you
break down.
over lubricate something, then it's gonna make wear and tear worse on that motor because it's not gonna be operating at its full capacity. And also think about like if you get oil like in a corner somewhere, the dust. Like, and dust is not good for a motor, right? Like you don't need dust in your motor. So that's why, like, when you don't ever want to over oil a motor when you're doing preventative maintenance. All right. So now overcycling. The process of turning a motor on and off repeatedly. And that occurs when a motor is at its operating temp and still cycles. So overcycling is not a good thing. Because it increases the temp of the motor and it destroys the motor insulation.
Well, a lot of them, when they overcycle, they don't even get time to like cool off.
Yeah. So like that's what I'm saying. Like the temp, we said that heat is bad in any form, shape, or fashion in mechanical world, the electrical world. Like heat destroys stuff, or it's a loss in any way you look at it. So heat problems, too much heat equals motor failure. So it destroys motor insulation, and a motor is not functional without proper insulation.
So is that part of the reason? I mean, I know why you run a contactor, but is that also another reason?
What are you talking about?
Like in controls aspect.
I think the contactor is more of line that's used for, so it has a way to shut off and it's not running.
Are you talking about like an overload protection or something?
Yeah.
We're about to do that on the next slide. Stop asking questions.
I'm sorry. I'm a step ahead of you, girl. I'm a step ahead of you.
Yeah, you are. So, anyways, because heat destroys motor insulation, and that causes short circuits with the windings. And the life of motor insulation is shortened as the heat in a motor increases beyond the temperature rating of the insulation. So the higher the temperature, the sooner the insulation fails, and this temperature rating of motor insulation is listed as the insulation class. So the insulation class can be found on the nameplate, the holy grail, right? So these are the different type of classes. So if you're running this motor and it's a class A, and it's running at 226 Fahrenheit, that insulation is going to start melting away, right? I mean, it's not rated for anything higher than 221. And let me just look up, well, y'all can see it right here. Let's see if you can see it up there. That's what a motor nameplate looks like. Y'all come look at it since y'all are in the classroom. Can y'all see that over here? So on the motor nameplate, it'll tell you what the model number is, the type, the phase, horsepower, hertz, amperage that it's rated for, volts, temperature, RPM, duty rating, serial number, all kinds of stuff. So if it's only rated for 40 Celsius, I mean, there's different classes. These are just showing examples. But you get the gist. If a motor's running hotter than what it's rated for, that motor's not going to last too long, right? Cool. And so heat buildup causes incorrect motor type or size for the job. So once again, if you're running a motor and you know that it's going to cause overheating and you're still running it, that motor's not going to last long. And improper cooling, ventilation. So think about, once again, you can refer that to like an AC unit. Why do they, like, for example, like my AC guy used to get on to me because he would come and like work on my AC, and my dogs had been like rooting all around my AC and like flipping up dust and dirt and dog hair. And that cooling fan, you know, it couldn't get suction. So literally, like, it wasn't properly ventilated, so it was burning up the motor and stuff. So literally, we paid like $1,300 for a new motor for our AC.
Oh, sounds
Right,
good.
so it didn't have proper cooling. So that motor wasn't rated for the heat that it was containing in its enclosure. So boom, eventually it'll burn out. That's why preventative maintenance is so important, because you need to be changing those filters and making sure there's no buildup or anything of that sort.
My favorite was the people that does the preventive maintenance that watch the video on YouTube and start turning their little fan to make it turn on.
Yeah, I don't know what you're talking about. Talking about AC unit? I don't know
Right.
anything about AC.
There's a video on YouTube, like the capacitor motors.
Mm-hmm.
If you just give them a kickstart, they'll go to their run winding, and that's what
Oh.
people do.
Oh, okay, I got you. Okay, so another thing would be excessive load. And I mean, obviously that motor's not, and if it's properly protected, then it wouldn't run anyway, because it's going to flip that relay like, hey, we got way too much load, we're kicking it off, right? Excessive friction, electrical problems, that's just a few to name. So once again, an overload is the application of excessive load to a motor, and if a motor is properly protected, should overloads harm the motor?
After this, can we ask questions?
Yeah. If a motor is properly protected, you're not cute, Dylan. If a motor is properly protected, should overloads harm the motor?
Well, I wouldn't think they would harm them.
If it's properly protected, should an overload harm that motor if it's wired up correctly and properly protected? Should it?
No.
No, because you're going to have relays in place. Literally, they're called overload relays in place.
So should you always overload, like put an overload on the motor?
I mean, I would think you need some type of protection
Yeah.
on that motor. Like, that's just me. But I mean, you know, just like we have like surge protectors in our house. You know,
I
like
was just thinking about that.
like I mean, if lightning strikes our house, we have surge protectors so it doesn't literally burn up our TVs or computers or stuff. So, I mean, if we have it in our home, I would assume that every single mechanical motor should need some type of protection on them. That's what I would say.
Okay.
Overload is just the most common type. I mean, let's see here. Uh-oh, I did something wrong. Anyway, that was the end of that slide, so. Oh, yeah, okay, anyway. What questions are we going to ask each other now?
I already jumped ahead of myself.
No,
well,
it seems
after-
like you covered all bases.
Well, after this, we're going to watch just a couple of videos on just motors and stuff. And I mean, this week I feel like you might have learned a little bit more than you did last week. So I was
Oh,
a
no,
little bit
learned
better
lot last
prepared.
week.
Well, I
I
mean,
didn't know nothing.
Well, I didn't
I didn't
know.
even know how to transform.
Well-
I at least understood where you're going with this. I did not know any of that stuff with the transform. Shoot, we still don't know series versus parallel.
well, we are about to have a quiz. I mean, on this stuff, so.
It's gonna be 2 questions.
Series or
Okay.
parallel? Yeah. All right, well, let me ask y'all a
Well,
few
that's
questions.
on our, well, that will be on the quiz you're gonna take later.
Oh,
Won't it?
okay.
What?
About the series or parallel?
Yeah, that's what I'm talking about. I'm just going to come up with a quiz for this all about motors, and of course it'll be open book. But it's good that you're at least seeing it one more time, having a look at the answer, because sometimes that helps you remember. Like, oh yeah, I remember looking at this answer.
That's gonna be this week.
So our lab this week, that's what me and Robbie's talking about, is we're going to get in there on those general purpose 3-phase motors, and you're going to wire it up in Y, because that's the only way you can apparently. But you're going to do high voltage, which equals, what does high voltage equal?
Series.
Thank you, Samuel.
Oh, I
That's
just-
it. That's it.
I was nervous
That's it.
I'm afraid people gonna throw a book at me.
That's
High
it.
voltage equals
You're getting this
60,
extra
and
credit
I
button
already
because,
have one. I got 2 of them.
or whatever. So,
I never got one.
well,
Okay, so we're wiring up and why?
yes, and Y. And then, so you're going to do a high and a low.
Yeah.
And then you're going to wire up the motor that goes to that motor control cabinet
Then somebody
and get
wired it up.
to see if you wired it up correctly.
So, oh,
Yeah, so that's why we're talking about you're going to lock out, tag out, because you're working with real voltage now,
have
pal.
we even tested whether it'll?
Mm-mm.
Well, I guess since I'm the 8 o'clock crew.
Well, Robbie's going to be out there with y'all when I'm not here.
Okay.
So, like, he wouldn't let y'all turn it on if he thinks it's going to damage nothing. He literally said, I'm going to come behind him and make sure.
I mean, me and Kyle are pretty smart.
I mean, y'all are smart, but everybody can make mistakes, even a professional. So,
And those are 3. Yeah, those are 3.
that's all we have. We don't have any single phase. I've done asked him. So, we have, and apparently, all we have is Y. So, but he said because the leads are already wired up internally, so the way that you would have to wire it up in Delta, he was saying, is if we had a 12 lead motor, so that way we could wire it up in Delta instead.
So how are we gonna wire that? Like from that J box onto the table?
And then test it.
Are we just gonna use that motor that we already bolted down?
Yeah, I think so. I'm not sure what Robbie was talking about. I know we got those other motors on the back table, but I'm not sure. I think those are VFD motors though, right? I think. I just remember seeing more motors in there.
There are a lot of.
That's what I'm saying. So I don't necessarily know if he's like talking about the motor that's on the table because it only produces 3 volts when you're running the drill.
Yeah.
I don't know. But Robbie's going to be out there.
Probably set up a new table then.
I'm
Go
sure.
ahead.
Because that way it's not
Sorry.
like discombobulated on there. Like that way you can actually just,
We'll run 3 tables.
yeah.
Okay.
Yeah. So Robbie will come up with something. But at least you're getting into, you're going to wire up that motor in low and high. And then Robbie will check the work, or I will when I get here. And then you'll get to run it to that motor control cabinet. And we'll double check and triple check to make sure before you cut it on because it will be fully energized. That's why we said you're going to treat it as lockout, tag out. It's going to be hot. We got to test it to make sure that it's not when we're working on it, right? So, that's what we have planned for this week.
Okay. Pretty
Well, we got to. We
fast.
was behind.
We do have to over it. Yeah.
But you're going to learn everything you need to know. I mean, like Robbie's done said, and I'll say it too, even though I'm not the most, confident person sometimes, me personally, I don't want you leaving here without knowing what you're supposed to know. So I don't want to, I wouldn't put my name behind somebody if I wouldn't have said we taught them everything that we were supposed to. You get what I'm saying?
I think you deserve to be more confident than what you are because you seem like you know what you're talking about.
Well, I do, but I'm just the type where
You're worried.
I don't want to get burned because I don't want to sound like such a smart butt and then be like, oh, you was wrong. Because Google can prove you wrong like that nowadays. Used to, they'd have to go do research and then it'd done be died down 3 days later and they'd be like, oh, you was wrong about that. But right now, all you got to do is say, hey, Google. And then you're wrong, So that's why, honestly, technology has made me a little bit less confident than I used to be because it's like somebody can prove you wrong just like that.
You're going to have a little kid that just started, just graduated high school.
They went to the WCCP in Jasper coming
Yeah.
out. You need to train the car. You got here wrong.
Now, if somebody was trying to argue with me about something I know, then I would have to school them and be like, listen, pal, you're wrong. But unless I know without a shadow of a doubt 110% that what I'm saying is accurate, I'm not going to say it with full confidence. I'm going to be like, let's look it up in the book just to make sure.
So my thing is, we put between that 3-phase breaker and that J box solid gauge wire.
All right.
Is that okay?
You might want to let Robbie look at it.
I mean, Robbie said it was okay for now.
Right. But
And I
is it
was
okay
more
for the
thinking-
lab now? That was okay for now last week.
I was thinking Cause it's in MC, it's
Mhm.
not like it's, in Romex.
Yeah.
So, I mean, we can take that solid out and just stick some stranded through there, and
Mhm.
just color code it and make it.
I think it'll be okay too, but I don't want to. Like I said, I don't want to say it's okay and then it
And
not be.
screw 'em up.
Yeah, and not be okay. So, but the
I'll
good
talk
news.
to Robbie and
Yeah, like I'm saying, the good news is he's gonna be in there because I haven't set up the lab yet. Like all day today, I've just been working on stuff to try to teach you guys about this and try to make it more fun than harmful. Because I hate just sitting here just reading out of the book. Like that is just annoying. It annoys me and it annoys y'all. So
Yeah.
I like doing this a lot better because it's more interactive.
You still want us to buy the book?
No, it's okay. Don't worry. I mean, it's already October. You got literally another month and a half in this class. Well, I would say 2 months. And that's not including like the break we're going to get at Thanksgiving and
The
Christmas and
interview in 5 weeks.
yeah. So, but anyway, but you're gonna done be good by then.
Oh yeah, I'm cocky as all get out, so I.
But you're gonna be fine. We're about to start actually working with live voltages here, and I think you're already learning more than you thought you would at this point. So I think you are. I don't know. But next week we're going to learn about reversing motors.
That's my jam.
So we're gonna start getting deep into that too, and then, do y'all want to go over how to troubleshoot a motor today, or would you rather do that when we're reversing them?
I'd rather do that.
What, when we're reversing them?
Um,
So do you want to go over troubleshooting when we're reversing, or do you want to know how to troubleshoot
I
it?
think we should go. Well, we should learn while we're reversing, so that we already know the forward.
Right.
So,
Yeah. Okay. Well, I just
so
didn't.
we won't
I
get
didn't want to
confused.
overload you. I mean, once again, I mean, if it was something that was like we got to learn it this week, obviously I would teach you. But I mean, I think that
like
it'll be
working
okay.
Troubleshooting procedures.
Yeah. Okay. Well, that's fine. We'll go over troubleshooting and reversing motors next week, so that might be a little bit longer of a lecture with a little bit more info, but it'll still be like this. Like it's not gonna be me reading out of the book or
Okay.
nothing. So let's look up AC motor types and let's see what it says. I wonder if I can even look up stuff. I can't look up stuff because I'm connected to Robbie's daggum SCADA thing. Dang it.
You could just send it to Canvas.
Yeah. That's true.
There's some YouTube channel.
Well
that I'll
done.
send you a link to.
Look at my baby.
It's adorable.
Look, this is a good tool for you guys. I think I've done showed you, Caden, but it's called the EE Toolkit.
Yeah.
And is it not neat though?
Yeah.
Like, I mean, it can literally tells you resistor color code. Let's see, Ohm's law, all kinds of junk. So, LED circuits, like, it's just got a lot of computations in it that is good. And let's see, like this is where I had made a switch slideshow for you guys that we never really got to go over. So let's see. So like, cause switches are pretty basic. I was gonna show you that slideshow whenever we was talking about line diagrams and stuff, but switches are pretty like, I mean, they're just basic. So anyways, I just wanted to show you that. So we don't have any more questions about that.
No.
So I'm gonna put up a quiz on Canvas, but it won't be due till next week.
Okay.
So it'll be due Monday of next week. That way we're gonna be diving into reversing. So you might have a quiz every week, but it's not gonna be more than like probably 10 questions. So but it's just good to see that info, even if you're looking it up in the book. So
I got a question.
what?
It's the person.
What?
I will not be in my control too.
Next semester?
This semester.
Oh, Robbie said solid is fine. He texted me that.
But,
Oh,
so I didn't have enough to pay for.
I got
another
you.
class.
I got
Will
you.
that affect me whenever I go take it? Either.
They'll
one of the
probably
next
do it in
two
the
semesters?
spring again, like this whole.
No,
So we'll be covering the same thing.
like you'll already have the basic knowledge of this.
Okay.
So motor controls 1 and 2 are kind of combined. Like it's literally the same book.
Yeah, I was just making sure like y'all was gonna like be ahead whenever I do the classes next.
Yeah, no. I mean, like at a certain point we will be, but it's not gonna be like, oh my gosh, I'm so lost that I can't.
Way far. Okay.
It's not gonna be like, oh my gosh, you know.
If it's just a little ahead, mentally, I think I can fill the gap.
Yeah. So like when does
I mean,
so you'll be out of this
I
class.
don't feel like
No, you're not. I mean, you're not. I can
feel like
tell. You can pick up on it, and you ask questions, and that's good because that means you have an intuitive mind and that you actually are trying to, receive the information. But like, you won't be so far behind that you'll be like hurting or nothing. So like, we're already starting to go over the basics. So this is basic knowledge of like transformers and motors and stuff.
It'll be same for hydraulics for
The industrial mechanics, yes, it'll be the same. So, like we're starting to get into deeper stuff now.
Yeah.
So you're already getting to see. Next week you'll see reversing motors. I mean, that's getting pretty deep into it. And then later on down the road, I mean, we've got a bunch of more chapters to cover, but it's not going to be hard once you have that basic knowledge. Like it's just adding to what you should already know from what we've covered up thus far to infinity till December something.
So
So,
will motor controls 2, we'll still be meeting at the same time, right?
and then you'll just pick whatever day you want to do your labs and stuff. So,
So nothing will change.
no, it won't change. You can
And
keep
that-
the same schedule.
Motor Controls 2 starts, what date?
I think,
Around October 13th.
yeah, middle of October sometime. But once again, it's not really going to affect you guys that are in motor controls 1 and 2 because they push up right up against each other. So it's literally like we're still going to be talking the way we are.
just,
Might just be more advanced labs or something.
just one day you're gonna wake up and you're gonna be hitting them.
Yeah, and you're going to be like, wow, we're still in motor controls 1. That's it. So it's not going to be any different. So let's recap and summarize what we talked about today. Okay? And then you guys can skedaddle or hang out, whatever you want to do. All right. Well, you got to hang out. You got hydraulics. So, let's see. What is the rotating part of the motor?
Shaft.
The rotor.
Oh yeah.
The rotor.
The
And
shaft rotates.
So, what is the stationary part of the motor?
The stator.
Stator, because it stays, right? Okay. And so, let's see. And when we're talking about 3-phase motors, we've got single voltage and dual voltage, right? So a single voltage motor, it only operates at 1 voltage level, correct? So personally, depending on the application, I would prefer a dual voltage motor because you can have a low or a high voltage, right? Okay. And if it's an option when you're wiring up a 3-phase motor, should you go with a low or high voltage? Higher, right? Why?
Less wear and tear.
Less current, right? Because the more voltage, less
But
current.
that's-
Right. Your answer. I mean, just the answer I'd be looking for is less current. But if you said that on the quiz, I would give you credit for it because
I would
it
say
is true.
Less current on the quiz.
Right. Okay. So then, what are they wired in? Like, what are the 2 types? Delta and Y. Right. Okay. And let's see here.
Series is more voltage, parallel is less.
Thank God. Is that finally clicking now?
No.
Oh no now.
We've had a breakthrough in motor controls. And that is high voltage equals what? Series. Okay. All right. Alrighty.
Sorry, I wasn't paying attention when you asked.
So here's a word problem for you guys.
Oh,
When connecting a dual voltage three-phase motor for high voltage, are the windings connected in parallel or series? What would you answer that on the question?
It's high voltage. Must be series.
Yes, that's how you would answer that on a test.
Holly, up my-
And it may or may not be on your quiz. Okay? So you need to be paying attention to this stuff because this is going to be on your quiz. Okay. What is overcycling?
Oh, when it turns on and off.
Right.
Very short.
Right.
Also causes overheating.
Yep. Sam, why is overheating a bad thing in a motor?
Because if a motor overheats, then bad things can happen. on it.
That's what's up.
Yeah, like crap's gonna hit the fan, bro. If a motor overheats, bad things are gonna happen.
We can break down the insulation.
Hey, put that on the test.
Yeah.
Bad things are gonna happen if a motor overheats. That was a good answer, Sam.
That guy.
Dude, you're funny. But the main problem is it destroys what of the motor, Sam? What we talked about earlier. Insulation, right?
Yeah.
So, like, it's overheating and destroys the insulation, and a motor cannot run without proper insulation. AKA, bad crap's gonna happen. So, and we talked about motor insulation class. And, okay, this is for all you guys to make sure you pay attention. What should we look at on a motor to see all the nameplate, right? Sam, you gonna look at that nameplate and see what it's rated for? Okay. And let's see. So some of the main reasons for heat buildup in a motor is the incorrect motor type or size for the application. So excessive load.
That's a pretty one.
There's my baby.
Aw.
And so excessive friction. Oh, this is something that I didn't specify earlier, but I mean, it's kind of, we talked about it though. That motors are designed with air passages that permit free flow of air over and through the motor. And airflow removes heat from a motor. So that's why some of those rooms that have the big old motors in them, like a plant, they have vents all in them. So they have vents in the ceiling and vents in the floor, because that helps natural heat flow out of the room. So main takeaway here is series equals high, parallel equals low.
And
Delta and
overheat.
Y.
Delta and Y are what three-phase motors are going to be wired in.
And
Usually
a
get
hot
on
motor
dual.
means crap hit the fan.
Dual voltage means you can have a low or a high. Single voltage means you can only have one or the other, right?
Yeah.
Okay. And
Read the daggone nameplate.
read the nameplate. If you have any questions, if you're troubleshooting something, you should know what the motor is capable of, right?
Yeah.
Boom, nameplate. That's why nameplates are important. So, and then, once again, if a motor is properly protected, should an overload hurt the motor?
No.
No. Right?
I really got confused when you was asking that question earlier.
But now you get it.
Yeah.
And so, oh, here's a good one, and I highlighted it. I forgot about this. Okay, so an electrician can observe the even blackening of all motor windings that occurs when a motor has failed due to overloading. So if it's not properly protected, there's going to be even blackening on the motor windings. And that is caused by the slow destruction of the motor over a long period of time. So that means it's been operating at too high of a load or whatever reasoning of why the overload is happening on that motor. So the windings are going to have an even blackening on it. So that could be a troubleshooting method. So
Look for
yeah, so look at your windings and make sure they're not damaged, and that could tell you if you have an overload on that motor or not, or whatever.
I know I've seen some burn up and they start bubbling up on the windings.
And so, and this also says no obvious damage or isolated areas of damage to the insulation are visible. So if your insulation's fine and you're like, well, what the heck is going on with this motor? Start looking at your windings and all that stuff, because that could tell you, hey, something's wrong, we have an overload issue. So, and it says current readings are taken at the motor to determine an overload problem. And a motor is working to its maximum if it is drawing rated current. So if it's drawing what it's rated for in current, then that means it is working to its maximum. So you're riding a very thin line there. If it's what am I trying to say? If it's pulling in the current that it's rated for, you have no room to wiggle. You know, like it could have an overload issue just like that. So that
If you're running at a lower voltage, you probably need to think about running
you would need a higher current rating on that motor, right? If you have a lower voltage. So if in that case the motor size might need to be increased, or the load on the motor decreased if overloads are an issue. Pretty simple, right? Now, let's see. There was one more. So next week we're going to go over troubleshooting and reversing motors. And I think that's it, my friends. So, yep, I think that's it. I think that's what I got for you. Is there any questions, Sam?
I was just gonna ask about that quiz that's due today.
Mm-hmm.
That
Did you turn it in and get a 0?
well, yeah, I did, but there was 3 questions there where I tried typing stuff and for stuff like that, and it just was like invisible.
You messaged me about that, didn't you? And don't worry about it. Like, I gave you credit because it was an open book exam anyway. But other people had that issue. But then again, some people didn't have the issue. So I have no idea why it did that to certain people and why it didn't do it to others.
What was his issue?
On the symbols quiz for hydraulics, not hydraulics, for motor controls. I'm sorry.
Mine, I had to leave, then come back.
Oh, so
Like
maybe
I-
you should have just refreshed the page and then came back or something.
Because I had the same issue. I pressed return, let it leave, then I went straight
Right.
to it,
Okay.
and all the pictures started coming.
So I don't know, Sam. But anyways, you got credit for it because I know you tried. Like, that's fine. But it's all good.
Mine did it on the hydraulics, so it
Mm-hmm.
didn't do on
I think it's because Canvas, they're trying to start this new quiz style or something.
Yeah.
So when we're making the quizzes, it's not the same as the old quizzes. Like, it's a different layout. So I think there's still maybe some glitches in that or whatever. But all right. Well, that's it. And you'll see.
Do you want anything to eat? Because I'm about to run to the McDonald's.